Okay, so today we are going to see an example of the correlation least square regression line steps 1 through 8. Okay, so we have a data set here. The values in the table are the daily morning low temperatures at a diner in the Northeast and the number of bowls of hot oatmeal sold each morning. So we have to take a look at the numbers. Notice that these are the low temperatures of the morning, and then the diner recorded how many bowls of hot oatmeal they sold over a period of 10 days. Our first step in the correlation process is to identify what are referred to as the explanatory and response variables. Those two variables are in fact the x and the y that we are going to use for graphing the scatter plot. So the explanatory variable is our x and the response variable is our y. When we identify these, we identify them by what they are, not just x and y, but by what they actually are. So the explanatory variable are the low temperatures of the morning. And the response variables is the number of bowls of oatmeal. Okay, we've done step 1. Now step 2 requires that we create a scatter plot out of this data. So once we decided in step 1 what is our x and what is our y, that is referring to the x-axis as our horizontal axis and the y-axis is our vertical axis. It's like quadrant 1 of a coordinate plane. So we need to just determine how we're going to set up our scales here. Since the low temperatures go from a low of 25 to a high of 50, I think I have plenty of room here to spread this out a little bit, so I'm going to scale it by 2's along the bottom. So we're starting with 0, and then we'll have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, and 52, 54. Okay, we don't have to go any further than the data. We need to make sure, though, that we include all of the data, all of the x values will fall on this scale. Okay, so the y values then are going to be the number of bowls of oatmeal, and they are very small numbers, going only up to 21. So I think I can do the same thing with the scale it by 2's. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And that should be enough points to get that in there. Okay, labeling your graph should happen also. I didn't leave myself much room to write it here, but these are the number of bowls of hot oatmeal. Barely see that. And at the bottom we have the daily low temperatures. Okay, so now it's just a matter of turning these into points. So we have the point 55. So I'm going to go out 50 and up 5. Make a point. Out 45 and up 6. 44, 6. That one was 44, 6. So 45, 6 will be here. Check them off as I go. 42, 8. 34, 10. 32, 15. 3212, $30.17, $26.20, and $25.21. Okay, so there's our scatter plot. We've now completed step 2. Doesn't take that long to do. Want to make sure it looks good. I suggest when you're doing this you use a pencil. It's easy to make mistakes. This is actually the 4th time I've done this, so hopefully I won't make any mistakes through the process. But when you do make mistakes, it's going to be easier to deal with if everything is in pencil. Okay, moving on to step 3. We want to visually determine whether the variables, that is the low temperature and the number of bowls of oatmeal, have a positive, negative, or no association. And we're going to write a sentence describing that association in context. Okay, so association means, do the variables have a relationship to each other? Does one thing perhaps cause the other thing to happen? That's the kind of question we're looking to answer here, or find evidence for or against the answer to that question. So in this case, if we were to draw a line in here to kind of estimate these points, it would definitely have a negative slope. If you remember slope from your algebra days, slope can be negative if it's going, slope is negative if it's going from down and to the right. It would be positive if it's going up the hill, up and to the right. So in this case, the slope of this line will be negative. So it has a negative association. And because those points look very much like a line, that's what gives it the strength of the association. The closer they are to being on a line, the closer that association is, or the stronger it is. So to write this sentence, we're going to say that the there is a strong negative association between daily low temperatures and the number of bowls of oatmeal sold. Okay, so that's our association sentence, just describing the association. Remember, you always have to use context of the problem. Don't just say there is a strong negative association. You have to tell me what it's between, and you have to use the words from the problem. Okay. The next one is we are going to write a causation question. Now, I will warn you that sometimes the causation question makes no sense, and sometimes you clearly know what the answer is to your causation question. But our job is going to be to figure out what that question is, and then provide evidence that supports an answer. So that's why I think it's important to at least have that question in your mind as you're going through this process. So the causation question here, and it's always related to the variable x, or the explanatory variable, and the response variable, in that order. So we're asking whether the x variable causes the y variable to happen. Okay, that's what the question is. So the question in terms of the low temperature and the bowls of oatmeal will be, does the daily low temperature cause the number of bowls of oatmeal to say increase. Okay, simple sentence there. Asking, does the daily low temperature cause the number of bowls of oatmeal to increase? Okay, the next part of the question asks us to look at some plots on page 519 in your textbook. If you don't have your textbook with you at the moment, we did look over these in class and discuss what those R values mean. Basically, when you have a negative association like this one, that means our correlation coefficient R is also going to be negative. And if you remember from class, R is a value that falls between -1 to +1, with negative showing negative and positiveness showing the slope of that line, and whether the association is negative or positive also. Never goes beyond -1 and +1, always in between. It's a decimal number. The closer it is to -1 or +1, the closer it will be, the stronger that correlation will be. So if you can review that page and have a look at what those look like, that's fine. If not, just take a look at it in class next time. So we're going to make a guess here about this correlation coefficient R, and that guess is going to be we've talked about this a couple of times. There were various guesses in the class, but I think we settled on, say, -0.90. Does have to be a decimal number. This is a pretty strong correlation, negative correlation. And later on, we're going to check and see how close we got with that guess. So at this point, having done just these steps, which was the first assignment out of the for this particular section, all I wanted you to do was base your guess on your association, on the scatter plot. Okay? In the next few steps, we're going to actually mathematically find that R, but this just gives you an idea of how these, what that relationship is between the two variables when you stop here and make this guess. Okay, step 6. This is where we're going to use the graphing calculator pretty extensively here. So hopefully you saw this demonstrated in class. If not, you're going to see it demonstrated right now, and then you'll have an opportunity to work with the calculator in class. So I have already entered the list. So we have those two lists of data, the low temperatures and the number of bowls of oatmeal. You access your list by hitting the Stat key. Move this up a bit. Stat, enter, and you can see that list 1 and list 2 are those two data sets. Okay, you want to take a look at your list and make sure that you've entered them correctly and that you have the same amount in each list, or you will get an error. Okay, back to the home screen. We're going to go Stat, over to Calc, arrow to the right, Calc, and this time we're going to use number 4, which is a linear regression.
Teachers, please be sure to enter your attendance before you leave campus today. There's an awful lot of attendance still not taken.
Okay, moving on. So we move down to 4 and hit enter, and from there we're going to put in the two lists that we're working with. So we are working with list 1 and list 2. So I'm going to hit the second button and the number 1 to get us that list 1. Then above the key that says 7, there's a comma. It's an important key to know. So we're going to hit comma and then second and the number 2 for list 2. So this is telling the calculator to do this linear regression with list 1 and list 2. Hit enter, and this is the important data that we want. Okay, so the first thing I'm going to suggest is that we just go ahead and write this data down, just as it appears. So we're using this y equals ax plus b, and then we have a, and that's going to equal -0.66, just rounding to the hundredths place. We have b, and that equals 35.7. if what you're seeing here right now. I'm going to have to stop a second and log this thing back on so I can see what's going on. And they just made me change my password. Okay. Alright. Then we're going to write down r squared, 0.91, and r negative 0.95. Alright, so let's talk about what these mean. This list of information is very important that you get this list off your calculator as soon as you can. You have 6 data sets to do in class, and you should get this information written down while you're in class, and then you can analyze it later. You can answer the questions based on those numbers later, but do get them written down. Okay, first of all, I hope you recognize this. It's the equation from algebra, which is y equals mx plus b. This calculator calls it a instead of m, and m stands for the slope. So this a is actually the slope of this line. B, from your algebra days, y equals mx plus b, was the y-intercept, and it still is now. So this is the y-intercept. It's where this line, and this is a line, crosses the y-axis. R squared we're going to talk about later. R is the one we just talked about just now, and our guess was pretty close because the actual R is negative 0.95. Okay, having that list of numbers is very important to your success here. We found out using the graphing calculator. We have found the slope. Now we're going to interpret that slope in regard to the low temperatures and the bowls of oatmeal. Okay, so first let me remind you what slope is. Slope is, on a coordinate plane, is rise over run, or in science we call it the change in y over the change in x. Okay, so as the y values change, the x values change. As the x values change, the y values change. And this is the kind of relationship we're looking for, and we want to know what this means in terms of the problem. So I'm going to suggest that you take this slope, and that's negative 0.66, put it on top of the fraction in the numerator spot for the change in y. And then for the change in x, we just have the number 1. So all we're doing is putting a 1 underneath whatever your decimal is. I know that looks awkward, but this'll let me explain what this means. Okay, with x, that's the explanatory variable. If we take a quick look back at the scatter plot, this is our daily low temperatures were along the x-axis. So temperatures were in Fahrenheit. Okay, should put that, Fahrenheit. So this 1 stands for 1 degree. 1 degree of Fahrenheit. 1 degree Fahrenheit. Then the change in y is referring to the number of bowls of oatmeal. Okay, so this is referring to, well, it's almost 1 bowl of oatmeal. It's 0.66 bowls of oatmeal. So this, in the numerator now, is the number of bowls of oatmeal. Okay, so now we have the context. So let's see what's going on here. What this is saying, that we have the change in y over the change in x. So for every 1 degree of temperature, the number of bowls of oatmeal is decreasing with the negative sign there by almost 1 bowl, or 0.66 bowls of oatmeal. So now we're going to put this into a sentence. And it'll be for every 1 degree and again that's temperature Fahrenheit. You could put that in parentheses. For every 1 degree, the number of bowls of oatmeal decreases, okay, that decrease is what our negative sign is saying, by 0.66 volts. So for every 1 degree of temperature, the number of bowls of oatmeal decreases by 0.66. This 1 degree, now notice I will tell you that when looking back here at the plot again, notice that as we move along to the right on the plot, X is always increasing. So you could say that X is increasing. And notice that as the temperature gets higher, the bowls of oatmeal is actually decreasing. So that's where that negative sign is coming in. So, in fact, you probably should put for every 1 degree increase. Okay, that should go in after you name what your variable is. For every 1 degree increase, the number of bowls of oatmeal decreases by 0.66. Now, this decrease is representing again that negative sign. If there is no negative sign, if it's a positive association, positive slope, you want to say increase, so that the two things would be increasing together. There are going to be many instances of the increase, that being the word increase. So you need to understand that all the words aren't going to be the same for each problem. They're unique to the problem. Okay, also number 7, using the graphing calculator, we're going to find the y-intercept of your line. Remember, the y-intercept may not be visible on the plot. Interpret the y-intercept in context, that is where x equals 0. So the y-intercept, according to the information that we took off the calculator, is 35.7. So that b, or y-intercept, is 35.7. Now you remember from algebra that the y-intercept is where whatever line we're going to draw on here crosses the y-axis. The y-axis is way over here. And notice, there is no 35.7 here. It goes up to 22, 24, 26, 28, 30, 2, 4, 5. Somewhere way up here is going to be 35.7. And it is, in fact, not on the graph. But it's there. It's way up there. So it only happens when x is 0. Okay? Remember, this is the origin. You don't have to have the origin in every plot you make, but it does happen to be there. So, thinking about that a minute. When x is 0, what is 0? What is x? Okay, so when x equals 0, well, x are the low temperatures. So that's pretty obvious that we're talking about 0 degrees. So when x is 0 degrees, look back at the plot one more time, y is the 35.7, and that is the number of bowls of oatmeal. So this fits nicely. I will caution you that not every time does x being 0 make sense for the data. It does not make sense every time. In this case, it does make perfect sense. So you're going to write the sentence anyway, even if it doesn't make sense, because one way or the other, it's providing evidence for us as to the strength of the actual correlation here and whether we can use this model or not. Okay, so we're going to write this, interpret the y-intercept in context. So this says that this particular, let me just change colors for the fun of it. All right. When the low temperature is 0 degrees, 35.7 bowls of oatmeal will be sold. Okay, 0 degrees. Now that it really does make sense that this diner owner who's keeping this data needs to know this. Maybe he knows next week that there are going to be several days of 0 temperatures or sub-zero temperatures, and so he needs to stock up and make sure that he has enough oatmeal. Alright, the last step in this lesson today is step 8, and again, using the graphing calculator, first of all, we want to write the equation for the line in the prediction equation. I think I must have typed that wrong there. So remember that our equation is in y equals ax plus b form, but y for our prediction equation has a hat and is referred to as y hat. That is our prediction equation. We're going to use it later on to actually do some predicting. Okay, so we put in the slope, which is the negative 0.66. We always have our x in a linear equation, and that will be plus the 35.7. So that answers the first part of this. This is our prediction equation. The second part of this says that we're going to talk about R. R we determined was negative 0.95, and we've also realized that how strong that correlation is. So we're going to write a sentence in context, and then we'll be done. When the correlation R equals negative 0.95, the association between daily low temperatures and the number of bowls of oatmeal sold is very strong. Okay, so it may seem that we're saying the same things over and over again, but as you actually put this data in and make these interpretations yourself, you get a stronger and stronger understanding of the data and what all the parts of this correlation and the least square regression line mean. There will be another lesson after the quiz. The quiz is for A2 and A3 on Friday. That is the 31st. Happy Halloween. And for B2, it will be on Monday, November 3rd. So take a look at this video, go over it more than once, make sure you've practiced this a few times at best prior to the quiz for your best effort.